everyone, in this video I'll be going over each question in this quiz review packet and how to solve each of them. So let's begin. The diagram below represents two concurrent forces. Which vector represents the force that will produce equilibrium with these two forces? Okay, so let's begin. Start with this keyword here, concurrent. And what that means is that these two forces are happening at the same time or simultaneously. And so we need to figure out which vector would cancel out, will produce equilibrium. So that means to balance them out or to cancel these two forces out. So we need to find a single vector that cancels both of these forces out. So if we have a vector that's going upward and going to the left, we need to have a vector that also goes downward and to the right. And each of these choices only show a single force vector, so we need to find a vector that does both of that at once. Just like that. And the only plausible answer for that is choice 3. Okay, moving on. Number 2. Forces F1 and F2 act concurrently on point P as shown in the diagram below. The equilibrium of F1 and F2 is... Once again, we see that keyword here, concurrently, so once again happening at the same time or simultaneously, and equilibriant. That's the same as the force that would put this in equilibrium. So just like number 1, we're looking for the force that balances both of these vectors. And this time we have numbers. So we have 10 newtons going north and 10 newtons going east. The resultant vector of these two would go like this and would be, we use Pythagorean theorem, a squared plus b squared equals c squared. Which is approximately 14 newtons, and that one is going northeast. So the equilibrium to this would go the opposite direction, equal in magnitude, 14 newtons southwest. And the answer for that is choice 1. A baseball is thrown at an angle of 40 degrees above the horizontal. The horizontal component of the baseball's initial velocity is 12 meters per second. What is the magnitude of the ball's initial velocity? Okay, so let's draw out the angle here. So we have initial velocity drawn here above the horizontal at an angle of 40 degrees. And it says here that the horizontal component is 12 meters per second. So that refers to the x component down here, which is equal to 12 meters per second. So this horizontal component of this vector. So we need to figure out what this is. The initial velocity. So we gotta work backwards with our equations here. So how do we find a horizontal component? We use cosine. So 12 meters per second is equal to V, which is what we're solving for, cosine of 40 degrees. Let me get my calculator for a second. Okay, so I got my calculator and we're going to solve this. So solving for V is going to get us 12 divided by cosine of 40 degrees, and V is equal to 15.7 meters per second. Choice 3. There we go. Now number 4. Well, I guess that's the end of the page, so we're gonna stop this for now and start again. Okay, a 15 meters per second velocity at an angle of 60 degrees above the horizontal. Find the horizontal x and the vertical y components of the velocity. So here we're finding the vertical and horizontal components of the 15 meter per second vector. So let's draw out our vector. 15 meters per second, and it's at an angle above the horizontal. 60 degrees, correct? Okay. Now we gotta use our trig function. So to find the x component, which function do we use? We use cosine. Oh, that looks ugly. Let me try that again. Okay. And that will get us 7.5 meters per second. And for our y component, we use sine. That's ugly. 12.99 meters per second. Alright, so if you show it like this, well, let me be more precise here about the units. So here, make sure you include meters per second here next to the 15, and your little degree sign here for each of the angles, and there we go. The x component is 7.5 meters per second, the y component is 12.99 meters per second, and okay. So the information given here will help us for numbers 5 through 9. A horizontal 20 Newton force is applied to a 5 kilogram box to push it across a rough horizontal floor at a constant velocity of 3 meters per second to the right. Okay. The key word here is constant velocity. When we have a constant velocity, what does that mean? Our acceleration is 0 meters per second squared. And when we have a 0 acceleration, what does that mean about our net force? It's also 0. Why? Because now that means our forces are balanced. Balanced forces. So when we draw our free body diagram, let's draw it over here for number 5. That means our applied force, F applied, is going to have a force of friction acting equal and opposite to balance it out. So that means if our F applied is equal to 20 newtons, that means it's also equal to the force of friction, just like that. Okay, now 6 through 7, calculate the weight of the box. So we have a 5 kilogram box. So our mass is 5 kilograms. And to find the weight, we use this equation. F of g is equal to mass times g, where our mass is 5 kilograms. And our g is equal to 9.8 meters per second squared. When you plug that into the calculator, you should get a value of 49 newtons. And just like that, it should give you full credit on the regions. Okay. Numbers 8 through 9. Calculate the coefficient of kinetic friction between the box and the floor. So this requires this equation. F of F is equal to mu times F of N, which is the normal force. So let's scroll back up a bit. if our frictional force here is 20 newtons, and we're solving for mu, sorry, F of n is the normal force, which is always equal to the weight acting equal opposite in direction. Okay, so that's 49 newtons. Doing 20 divided by 49 gets us mu. And our mu is 0.41. Does it have units? No. It's just a coefficient. So we leave it as is. Number 10. A 4 kilogram object is accelerated at 3 meters per second squared north by an unbalanced force. The same unbalanced force on a 2 kilogram object will accelerate this object toward the north at... Okay, so this is a simple F net equals NA problem. Okay, so F net is equal to mass times acceleration. We gotta figure out the net force in the first scenario. That's what we're gonna do in red. So F, F net is equal to 4 kilograms times 3 meters per second squared. 4 times 3 gets you 12 newtons. Now in blue, we're gonna take this same unbalanced force, bring this over, to find the new acceleration for a smaller object, smaller mass. 12 newtons is equal to 2 kilograms times acceleration. 12 divided by 2 should get you an acceleration of 6 meters per second squared. Choice 2 here. Okay. Now number 11. Oh, it's cut off here. Oh well. Let's solve it here and see if it matches up on the answers on the next page. Okay. What is the weight of a 2 kilogram object on the surface of the Earth? So this 2 kilograms is our mass. Weight is F of g. Use this equation. F of g is what we're solving for, so m is 2 kilograms times g, which is 9.8 meters per second squared. 2 times 9.8 meters per second squared is equal to, so it should be 19.8. Let me double check. No, it's 19.6. My bad. 19.6 newtons. And it's not either of these choices, so it's got to be choice 3 or 4 on the next page. And then what do you know? It's choice 4. 19.6. Okay. What is the acceleration due to gravity at a location where a 15 kilogram mass weighs 45 newtons? Okay, acceleration due to gravity. So that refers to our variable g. And if we're given a weight of 45 newtons, that's F of g, and this is our mass, m. So we're just going to do it here. F of g is equal to mass times g. If our weight is 45 newtons, and our mass is 15 kilograms, we're solving for g here. 45 divided by 15 gets us a g of 3 meters per second squared. Choice 3. 3 for 3. Alright. Number 13. The weight of a typical high school physics student is closest to... Well, how the heck do we know what the weight of a typical high school physics student is? So, first things first. Most of us know our units in terms of pounds. But in physics, we use kilograms. So here's an approximate conversion. So 1 kilogram is approximate... Well, that's ugly. Let me erase that. One kilogram is equal to approximately 2 pounds. Okay. And we're given weights here in terms of newtons. So, first things first, we got to convert each of these to kilograms and convert it to pounds to see if it falls anywhere near our frame of reference. Okay. So, the quickest way is to divide each of these by approximately 10 using this equation. If this is f of g, all of these are f of g, and we're looking for a mass here, we got to do f of g divided by g. And since g is 9.8, we could approximate that to about 10 meters per second squared, making it easier on us to do our conversions. So if you look at each of these, this one's about 150 kilograms. This one's about 60 kilograms. This one's about 12 kilograms, and this one's about 6 kilograms. Now, when we convert each of these to to pounds, times it by 2, this one's about 300 pounds. That's too much. This one's about 120 pounds, maybe. This one's about 24 pounds, too light, and this one is even lighter. So the only plausible choice here is choice 2, 600 newtons. Okay, now, number 14. A 0.5 kilometer when sitting on a horizontal shuffleboard court is slowed to a rest by a frictional force of 1.2 newtons. What is the coefficient of kinetic friction between the point and the surface of the shuffleboard court? Okay. So let's pick out our newtons here. Let's pick out, our variables. So it's asking for the coefficient of kinetic friction, mu. That means we're probably going to use this equation. We're solving for mu, our f of f is here. But do we have an f of n? Well, we have mass. And using that, we can find our weight, which will also give us our normal force. Okay, so it's a two-step problem. So let's first find the weight. This should give us about 4.9 newtons, which is also equal to our normal force. So plug this in. Now we have 1.2 newtons is equal to mu times 4.9 newtons. 1.2 divided by 4.9 gives us our mu. Oops. And we get 0.24. Choice 1. There we go. A 300 Newton car skids on a horizontal concrete wet road. What is the force of friction on the car? Okay, so this question asks for the force of friction on the car. So that means we gotta use this equation. That looks ugly. Mu times f of n. Okay, so we're looking for the force of friction. Do we have a mu? Well, in this question, we have a car skidding on a horizontal concrete wet road. So a car has rubber tires. And we're on a concrete wet road. So in your region's reference table, there are coefficient of frictions for different surfaces, different materials on different surfaces, and there's one specifically for rubber on wet concrete, and that number is 0.58. And now we have a mu, but do we have a normal force? They do give us here the weight of the car, 300 newtons. The weight of the car is the same as the normal force, so we have both pieces of. Okay, now let's solve. F of F is equal to 0.58 times 300 newtons. Multiply it out, and what do you get? Should get 174 newtons. Choice 1. Okay, so this is the last question. The graph represents the net force acting on an object as a function of time, during which time interval is the velocity of the object constant. So on the next page we have the graph, so let's pause in here and turn to the next page. Okay, so looking at this force versus time graph, we have to look for the interval where the velocity is constant. Okay, so when do we have a constant velocity? When acceleration is equal to 0. When do we have 0 acceleration? When our net force is equal to 0. That means our forces are balanced. So here we're looking for a time interval in the graph where we have 0 net force. And the only place on the graph that falls on is here, in this interval. And that is interval 3 to 4, choice 3. And that's it.